In this example, we're going to simplify an expression using the rules of exponents. When you're simplifying expressions using the rules of exponents, there is no particular one way that works the best. What I like to tell students is you pick one thing that you can see that needs to be done and you start there. And at each step, you just identify one thing that needs to be done. When I'm looking at this particular problem, one thing I notice is that we have the numerator raised to an exponent. So we're going to use the power rule of a product, and we're going to raise each item to that exponent. This is 3 cubed. Remember, when you raise an exponent to an exponent, you multiply. Therefore, this is going to be x to the 3 times 3, or 9th power. And that'll be y to the 4 times 3, or the 12th power. Since the denominator does not have any exponents on it, we're just going to bring it over. At this point, let me go ahead and simplify 3 cubed. 3 cubed is 27. Now let's see what we can simplify. I notice that 27 and 6 are both divisible by 3. So we're going to divide each of those by 3. 27 divided by 3 is 9. And 6 divided by 3 is 2. For the variables of x and y, we're going to use the quotient rule. Remember, the quotient rule says that we subtract our exponents. For the variable of x, we have 9 minus 1, because this is understood to be 1 here. So that's going to be x to the 8th. And y will be 12 minus 3. 12 minus 3. Or y to the 9th. Since we have no variables that are the same on the numerator and the denominator, and since our coefficients of 9 and 2 cannot be simplified any further, we are done with this problem. And now let's look at a second example. There are a couple of ways that we can work this problem. I'm going to choose one problem as I see fit, and we'll work it that way. The first thing I want to work on is trying to simplify what's inside those parentheses. The -4 and the 5 cannot be simplified, so I'm just going to rewrite those. Now, what I can do with the variables is I can subtract the exponents. Be careful when you're subtracting these exponents because you're also dealing with negatives. So for the x, you would have 4 minus a -1. With the y's, you would have -2 minus 4. So let's simplify this. X to the 4 minus -1, that's the same thing as adding a positive. So in reality, you have 4 plus 1, or 5. Y, it would be -2 minus 4, which is -6. Now let's take this negative exponent here and distribute it to each item inside those parentheses. We would have -4 to the -4th. An exponent raised to an exponent, you multiply. So 5 times -4 is -20. -6 times -4 is positive 24. Now what I'm going to do is I'm going to take care of my negative exponents. Everywhere I see a negative exponent, I'm going to change the position where it is. If it's originally in the numerator, I'm going to move it to the denominator. If it's in the denominator, I'm going to move it to the numerator. This will change the exponent to a positive. So our 5 to the -4th comes up and becomes 5 to the 4th. Since y to the 24th is a positive exponent, we leave it in the numerator. And in the denominator, we'd have negative 4 to the positive 4th and x to the 20th. Last thing I need to do is simplify my 5 to the 4th and negative 4 to the 4th. Using a calculator, we can find that 5 to the 4th is 625, and negative 4 to the 4th is 256. And this is my final answer. Now, just to clarify, because 5 and negative 4 will not simplify, you can rest assured that 625 and 256 will not simplify. Okay?